Hi everyone, this is Ashrita. I am doing my PhD Soil Science in Tamil Nadu Agriculture University, Coimbatore. I have done my UG in Agriculture College and Research Institute, Madurai, and PG in TNAU, Coimbatore, and I am continuing my PhD in the same campus itself. Actually, I will be handling a part of soil science, and I am very happy to be a part of it. First of all, I would like to convey you that because of this COVID pandemic situation, Phoenix has made an effort to conduct the virtual classes and test series. Actually, the online classes will be conducted in live, but the stored videos will also be available in the Phoenix mobile app. In case if you have missed any classes and for your further future references, you can make use of the stored videos. And the online test series will be conducted as mock test, unit-wise test, and class test, etc. So that you can strengthen your subject knowledge as well as you can gain the confidence on the subject. You will also be practiced to manage the time for exams. We are happy to inform you that we will be providing you a subject material. It will be both subjective and objective material compiled with the help of several resource persons and subject matter specialists. It will be comprising A to Z of the subject. So it will be more useful for you. And also the objective material is also very crispy enough for you to revise during the examinations. And we will be handling the classes in a sequential manner so that you can have a clear vision on the subject and also you can have a good relevancy. So finally, I can promise you that at the end of the day, you will be fit enough to fight in this competitive world. And I wish you for a shining future. And I will be going to my demo class. Let me share my screen. And today I'm going to handle you soil fertility, which is a very important branch of soil science that it deals with the nutrients, their role, their deficiency and toxicity and fertilizer recommendations and so on. So this is considered to be an application oriented part of soil science. I will be handling a small pinch of this subject. And first of all, you should know what is the difference between a soil fertility and soil productivity. The soil fertility, it is nothing but the ability of the soil to supply the nutrients, whereas soil productivity, it is the ability of the soil to produce the crops. This is a very small difference between them. And there is a famous quote in soil science that is all productive soils are fertile, but all fertile soils are need not to be productive. And if you are going to deal with the nutrients, you should have a clear idea on this essentiality of nutrients. And this criterion was given by Ornon and Stout in the year 1939. Actually, if a nutrient element is said to be an essential nutrient only if the element satisfies all these three criterions. And come to know what are the three criterions. That is, the plant cannot complete a function or complete its life cycle without this nutrient. Its deficiency can corrected by only the application of the same nutrient, and it takes direct role in metabolism. And an element should satisfy all these criterion to become an essential element. Accordingly, there are about 17 essential elements which are required for the growth of plants. And there is another type of nutrient called beneficial nutrients. This is a small difference between the essential nutrient and beneficial nutrient. That the main point from the slide is that the essentiality of nutrient criteria was given by Arnan and Stout. You should remember this. This is a common question which will be asked in most of the competitive exams. And next, coming to the essential nutrients. As I mentioned earlier, there are about 17 essential nutrients, and actually earlier there was 16 essential nutrients and nickel was the last added one, so that there are 17 essential nutrients, and these are all the 17 essential nutrients. You can see the slide. From that, carbon, hydrogen and oxygen are considered to be the basic elements, and they are not obtained from the soil. They are obtained from the air and water, whereas other nutrients like nitrogen, phosphorus, potassium and some other micronutrients and all secondary nutrients, they will be taken up from the soil as well as from the added fertilizer. Okay, and I will be explaining the different types of nutrients. And the two different types of nutrients are macronutrients and micronutrients. how they are classifying this, that is based on the requirement of the plant. If the plant requires the nutrient in large quantity, they are considered to be as macronutrients. If it requires in very small quantity, they are considered to be as micronutrients. The another name for this micronutrients is the trace elements. And carbon, hydrogen and oxygen are required by the plants in very large quantities, and mostly 90 to 95 percentage of the plant dry matter composed of carbon, hydrogen, and oxygen. And this macronutrient is also divided into two types, namely the primary and secondary. Primary nutrients are N, P, and K. Secondary nutrients are calcium, magnesium, and sulfur. And coming to the micronutrients, they are required in very small amounts relatively in terms of parts per million. Like they are classified into two types, namely cations and anions, mainly based on their ionic charge. We all know that the cations are positively charged and anions are negatively charged. The micronutrient cations are those like F, iron, manganese, zinc, copper, and nickel. All these are cationic micronutrients, whereas anionic micronutrients are boron, molybdenum, chlorine. Okay, you should remember one thing, that plants can take only nutrients in the form of ions, but there is a only one exceptional nutrient, that is boron. The plant can take boron either as a boric ion, anion, or sometimes it can take boron as a neutral boric acid. So you should remember this boron is an exceptional nutrient. And as I mentioned earlier, there are several types of nutrients. One is essential nutrient, another one is functional nutrients. Those nutrients which satisfy the criterion or of essentiality are considered to be essential nutrient, whereas those which does not satisfy the criterion are considered to be as functional or metabolic nutrient. They are also called as beneficial elements or potential micronutrients. And these nutrients will be useful for some plants, but they are not mandatory for all the plants and all the organisms. So they are classified as functional or metabolic nutrients. Examples of functional or metabolic nutrients are silicon, sodium, aluminium, cobalt, selenium, and vanadium. For example, the silicon is mandatory for diatoms, but it is not mandatory for all the plants. Therefore, they are considered to be as functional or metabolic nutrients. And next, while dealing with the nutrients, you should be able to know the different status of nutrients in soil. They are deficient. Deficiency, we know that the availability of nutrient is lesser than that of the requirement of the plant. Hence, then the status of nutrient is said to be deficient. If the availability is sufficient enough to satisfy the requirement, then the state is called sufficiency. If the availability of nutrient is large enough to cause toxicity in the plants, then it is called as excessive or toxic. These are the three nutrient statuses in the soil. While telling these things, I came across two important terms. One is luxury consumption. You might have here luxury consumption is specifically concerned with potassium and sometimes with chlorine. Chlorine, that is nothing but their availability will be very large in the soil. Therefore, the plants take up the large amount. It will be greater than the sufficiency but lesser than the toxicity. The plant will take up this nutrient in large amount, but it does not cause any symptoms in the plant, does not cause any toxicity to the plants. Then this condition is known as luxury consumption. It is specifically concerned with potassium. You should remember this. Sometimes they may ask in the exams. And hidden hunger. You might have heard this term, hidden hunger. It is nothing but the plant will not show the deficiency symptom of that nutrient. And suddenly, after a long time, it will wilt. It does not show any symptoms, and such condition is known as hidden hunger. And these are the concentration of the nutrients in the plant tissues. As I mentioned earlier, the macronutrients will be required in large quantities and micronutrients will be required in small quantities. Large quantities they have mentioned in terms of percentage, and small quantities they have mentioned in terms of milligram per kilogram. You can go through this, that nitrogen, if it is present 1 to 5% in plants, it is considered to be sufficient. If it goes more than 5%, it can show some toxicity symptoms. If it is deficient less than 1, it is deficient and it shows some deficiency symptoms. Like this, you can go through this. And next, I will be going to deal with the concepts of nutrient availability, mobility, and nutrient uptake. I will not be going deep into the concepts. I will be telling what is the concept and who gave the concept. That itself is enough for such competitive exams. And first, while dealing with the soil science, you should know the law of minimum. It is a very essential basic law regarding the nutrient relationship in soil. Law of minimum, it was given by Liebig in the year 1840. You should remember this. Justice von Liebig is considered to be as the father of agricultural chemistry. And the law states that even if all the nutrients on the soil are present in optimum, even if one of the nutrient is limiting, that decides the deficiency. And next is the Michel's law. Actually, Michel's law is related with the law of diminishing returns, which we will be dealing in economics, etc. That is nothing but the increase of nutrients will cause increase in growth of plant, but after some time, the addition of nutrient will cause the cause a toxicity problem in plants. That is what Michel is told. And there are two laws given by Michelich. That is, one is the law of physiological relationship, and one is the growth law. Accordingly, they will ask sometimes in JRF and SRF exams, they are asking that in Michelich law, what does the A represent? What does the B represent? So you should know what is the equation and what does the terms represent. So this is the equation: log A minus Y is equal to log A minus CB, where A represents the maximum yield and Y represents the obtained yield and B represents the soil test value. Based on these factors, we will be recommending the fertilizer. So this is a basic law for fertilizer recommendation. And Bray has modified this Michelis equation, and finally the equation was termed as Michelis-Bray equation. He has added one more term called C and X, where X represents the amount of nutrients to be added in the soil. So this percentage sufficiency concept and all, you just know who gave this concept. Bowley gave this percentage sufficiency concept. That itself enough. And law of maximum. This is what you should not get confused. The law of minimum was given by Liebig and law of maximum was given by Wallace and Wallace. You just remember these things. That itself is enough. And next is the Bray's concept. Bray has given two major concepts, namely concept of nutrient availability and concept of nutrient mobility. You just remember Bray gave two concepts and what are all the concepts and what is the year. And based on this concept, the nutrients have been classified into mobile and immobile nutrient. Okay, mobile nutrients are they are freely mobile in the soil. They easily move from one location to the another location. They will be easily available to the plants. Whereas immobile nutrients are those they get localized in a specific location. They will not move from one place to another. Hence, they are considered to be as immobile nutrients. Actually, I would like to say the scientific fact behind, then it will be useful for you if you have any confusions. So why these nutrients, mostly all anions are mobile and mostly all cations are immobile. What may be the reason? That is, the clay will be usually negatively charged. Therefore, if all the anions are negatively charged, we know the basic signs, that is, like poles repel. Therefore, these anions will repel from the clay. They are freely mobile. Therefore, once the cations are positively charged, the clay is negatively charged. They get like poles attract. Therefore, these cations get attracted to the clay, negatively charged clay, and remains immobilized in the clay. Therefore, they are considered to be as immobile nutrients. And this is the tabular column showing the mobile and immobile nutrients in soil as well as in plants. You should know one thing in the slide, that the phosphorus is an anion, but it is highly immobile in soil but highly mobile in plants. Okay, this is a common question they are asking in most of the exams. You may ask, phosphorus is an anion, then why it is immobile in soil? Because the phosphorus is a exceptional anion. It is undergoing several fixation processes in soil and remains immobile in soil, but it is highly mobile in plants. And based on this mobility and immobility in plants, the deficiency symptoms occurs in the plants. I will be explaining in the next slide. This is a very important slide you have to go through. Mobility and immobility of nutrients in plants and soil. Okay, and these are all the ionic forms taken up by the plants. Usually, the mobile and immobile elements in soil will be represented in the ionic form because the plants can take up only the nutrients in ionic form. And this is the picture which clearly shows the deficiency symptoms. As I mentioned earlier, that mobility and immobility of nutrients in plants decides the location of deficiency. Okay, in case if a root takes up the mobile nutrients, the nutrient is mobile now, so it moves from the lower leaves, young leaves, so it moves to the top of the plant. Therefore, the deficiency symptom occurs in the older leaves. In case for immobile nutrients, if the root take up the immobile nutrients like calcium or iron, as they are immobile, they remain in the older leaves itself. They don't move to the younger leaves. Therefore, the symptoms appear in the younger leaves. The mostly the symptoms of immobile nutrients occur in the younger leaves, and mobile nutrients occur in the older leaves. A simple example, for nitrogen, it shows the yellowing symptoms in the older leaves because it is highly mobile in plants. But sulfur, it also shows the yellowing in the younger leaves because it is an immobile nutrient. You can simply correlate this with the deficiency symptoms. We will be explaining in deep of this deep the functions of all these nutrient elements, the deficiency and toxicity symptoms in further classes. And this is just an overview of what's happening in plants because of this mobility. And finally, I thank you all for your pleasant wait. Let's meet in the next live class. Bye.